Welcome to the DIY Honda Garage channel. The DTC P16E5 indicates a LIN communication error, specifically involving the communication between the Powertrain Control Module, PCM, and the DC-DC converter. The PCM is a critical component responsible for controlling various functions within the vehicle's powertrain. Located in the engine compartment, it receives and processes signals from various sensors and modules, including those connected via the local interconnect network, LIN. The DC-DC converter is another significant component that converts voltage levels to provide necessary power to different vehicle systems. A failure in communication between these components leads to the PCM detecting an anomaly and storing the DTC code. Identifying the root cause for this error is essential for ensuring proper vehicle operation and safety. The error described by DTC P16E5 occurs when the PCM cannot receive signals from the DC-DC converter through the LIN communication system. The LIN, or Local Interconnect Network, is a protocol that allows various electronic components in a vehicle to communicate. When this communication fails, the PCM detects this disruption and records the DTC to signal an issue. The affected components include the PCM, located in the engine compartment, which oversees multiple electronic functionalities, and the DC-DC converter, responsible for voltage regulation. Together, they ensure seamless vehicle operation, and any communication disruption can lead to degraded performance or potential safety risks. There are several potential causes for the DTC P16E5 error code. First, circuit issues may exist, including open or shorted wires in the LIN communication circuit connecting the PCM and DC-DC converter. A fault in the DC-DC converter itself can also lead to communication failures, causing the PCM to assume there is an issue. Additionally, the PCM could potentially be malfunctioning, resulting in an inability to correctly identify or process signals from the DC-DC converter. Thus, careful inspection of both the electrical connections and the components involved is crucial for accurate diagnosis. When the DTC P16E5 is triggered, the driver may notice various symptoms indicating an underlying issue. One common symptom is the illumination of warning lights on the dashboard, which serve as alerts for potential powertrain problems. The vehicle may also experience reduced performance, such as sluggish acceleration or decreased power output due to improper voltage regulation from the DC-DC converter. Additionally, electrical malfunctions could arise, affecting other systems within the vehicle, such as lighting or infotainment functionalities. Recognizing these symptoms early is important for preventing further issues and ensuring optimal vehicle operation. The first step in troubleshooting the DTC P6E5 error is to turn the vehicle to the on mode and wait for 10 seconds. This step is crucial as it allows the vehicle systems to initialize and ensure that all electronic components are powered up and ready for inspection. It sets the stage for the diagnostics that follow, helping to identify if the error persists after the systems have had a brief moment to self-check. Monitoring any warning lights or dashboard indications during this period can provide initial insight into any ongoing issues within the vehicle. Proper execution of preliminary steps is vital for accurate diagnostics. In this step, inspect the IG1 ACG circuit while ensuring that the battery voltage is at normal levels. This involves testing the integrity of the circuit, which plays a significant role in the vehicle's ignition system. If the circuit shows signs of abnormal resistance or shorts, it could indicate a potential break or malfunction, requiring further investigation. The test should ensure there's less than 1 ohm resistance if the issue is related to the LIN communication. Proper voltage management is essential for consistent electronic functionality, and any discrepancies here could exacerbate communication errors, leading to the DTC being recorded. The third step involves a detailed inspection of the LIN BAT sensor circuit to determine if there are any issues such as short circuits or open wires. This is critical since the LIN protocol facilitates communication between multiple components in the vehicle, including the PCM. If the inspection reveals that the circuit is shorted to ground or has open wires, it may affect the PCM's ability to receive signals properly. Consequently, it's important to ensure the resistance levels meet specified values, particularly that there's more than 1 megaohm resistance in case of a detected short. This step is pivotal in isolating the specific circuit issue to rectify the communication error effectively. The fourth troubleshooting step requires inspecting the DC-DC converter itself and ensuring its circuit integrity. Since the DC-DC converter directly influences voltage supplied to the PCM and several other components, any failure or abnormality here can result in communication errors. This process starts with verifying the connections and testing the component functions under normal operational conditions. The goal is to determine if the component itself is faulty. If the converter passes this inspection while the DTC remains, it indicates that the issue is likely with other connected components, rather than the DC-DC converter itself. Finally, if all previous inspections indicate normal conditions, the last step is to inspect the PCM. As the central unit that processes information from various sensors and components, any malfunction at the PCM level can lead to communication errors, such as the DTC P16E5. This inspection evaluates the PCM for any physical damage, disconnections, or malfunctioning processes. It's important to isolate this as the potential fault before concluding that further repairs or replacements are necessary. If found defective, replacing the PCM may be required to restore normal communication and operational functionality to the vehicle. After completing all troubleshooting steps and necessary repairs, final verification is essential. This involves rechecking all electrical connections and ensuring that everything is securely fastened and correctly reconnected. Once verified, clear the DTC from the memory of the Powertrain Control Module using Honda Diagnostic System (HDS) or appropriate diagnostic tools. Following this, conducting a test drive is crucial to verify that the issue has indeed been resolved. During this drive, observe for proper vehicle performance, ensuring that all systems are functioning as intended and that no warning lights reappear. This comprehensive final step confirms the effectiveness of the repairs. Engaging in preventive maintenance is critical for avoiding future issues related to DTC P16E5. Regular system checks should be carried out to assess the health of the vehicle's electrical components, especially focusing on the LIN communication network components. It is advisable to make sure all connections, including those of the PCM and DC-DC converter, remain secure and free of corrosion. Additionally, routine inspections of the vehicle's battery and related electronic systems can preemptively identify potential failures before they escalate into significant problems. By investing time in preventive measures, car owners can help sustain vehicle performance and reliability. In summary, the DTC P16E5 signals a LIN communication error, primarily involving the PCM and DC-DC converter. Key causes include circuit issues, faulty components, or PCM malfunctioning. The diagnostic process involves several critical steps: checking circuits, verifying the health of components, and conducting thorough inspections to isolate problems. Understanding the undertakings during troubleshooting is essential for addressing issues accurately and promptly. Lastly, committing to regular maintenance of the vehicle's electronic components aids in the prevention of such issues, thereby enhancing performance and reliability in the long run. Please like and subscribe to the channel. See you next time.